Hi guys. So in this video, I want to explain the various operations of stacks. So I'm going to use the explanation on tutorialspoint.com, and I'll go through the various algorithms and pseudocodes there, and then we'll use that in conjunction with our stack diagram here, so that we can explain them step by step, and you can understand what's going on. So the stacks the operations that you want to look at are basically, you can read the whole document. I think it has got good information, but we just want to focus on the basic operations, and that's to push. Push is adding an element to the stack. Pop is removing an element from the stack. Pick is basically trying to see what is the top element in the stack, or retrieving the top element in the stack. And isfull is checking whether it's full, and isempty is checking whether the stack is empty. So we're going to start with push and pop, and then we move to the rest. Because the moment you understand pushing and popping, then picking is full and is empty becomes simple. So let's move to the push operation. So basically, when you want to push something, as we said, you want to add it into the stack. So what we're going to look at firstly is the algorithm. What are the step-by-step process that you take in order for you to be able to push something into an element? And then after that, we'll look at the programmatic implementation of an push operation. That is, we'll look at the pseudocode to say how do you actually program it so that it makes sense. So the first step you're going to take before you push something or before you put anything into a stack, you first have to check if it's full. Okay. So if the stack is full, then you do nothing. You produce an error and then you stop execution. But if the stack is not full, what you do now is you move the top pointer to point to the next empty space. We'll see this when we're now doing it programmatically. And then when the top point has been moved, you then add elements. Add the element to that location where the top is pointing, and then you return success. So let's look at the pseudocode. So I want to look at this one here. Okay. So firstly, you're going to declare your function. Your function, we call it push, void push, and then it takes an element of an integer, which is data. So we're going to check first with this operation if the stack is full. Okay. So if the stack is not full, what you do is, let's say the stack is this one with two elements here. Okay. And you want to add another element. Firstly, you check if it's full. So in this code, is saying check if it's not full. This is what you do. Otherwise, if it's full, you just print could not insert data, stack is full. If it's not full, that's what the exclamation mark here means. If it's not full, then move the pointer to the next empty space in the stack, and that next empty space is what is top plus one. So top is here, right? And then since you want to add a new element, the new top element will be the one that you have added, right? So you move the top pointer to the next empty space, which is this one, okay, which is position one. Here, position 0 has got 2, but the new element is going to be put in position 1. So you move the top pointer to position 1. And then in position 1, which is stack top, which is represented by stack top, that's where you are going to put your data, which is your argument here. So as you can see in this part now, we have moved our top pointer to index 1. And in index 1, we now add our value 3. Okay. So basically put here, we have declared our function. It's called push, and it takes an argument int. Then on this line, we are checking if the stack is full. If it's not full, then we move the pointer to the next the next empty space, because in that empty space, that's why we are going to put our new element, and that new element becomes the top element. So this is acting as a pointer. This top variable is acting as a pointer, which is pointing the top element in the stack. That's the job of this top variable. And then the next line, stack top, in our stack, okay, we then add at position top, we then add our data. And remember, top is pointing to the next highest index. So that means we are adding our data to the next highest index. So in this instance, what we are basically saying is, firstly, we are checking if our stack is full. it's not full, right? So if it's not full, then what we do is we move the top pointer to the next free index. Okay. Let's say in this instance, if there was 2 in the stack already, we move it to index 1 where there's nothing. Then we add our element 3. Then we can also add another element where we check, where we also move the top element, the top index from position 1 to index 2 here. And then we add a new element. Here we've added a new element. Okay. But if the stack is already full, it means the top index is already at the maximum point of the stack. So if it's already full, you cannot move that top pointer to another index of the stack because there's nowhere else for it to go. It has reached the end here. Okay. So the only operation that you can do now is to check what the top element is, to remove, which is to pop, and to check if it's empty or it's full. That's all you can do. So you can no longer add anything else because the top pointer has got nowhere else to go. Okay. So let's look at the pop operation. Another thing that you need to remember from the first video, remember we said you need to declare the maximum number of elements that a stack can take. Okay, so this is not a limitless data structure. No, it has got a limit. So if you want 20 elements in your stack, you declare that your stack can take 20 elements. Okay, because that's the highest it will go. So always remember that it has a limit. So let's look at a pop operation. Now a pop is different, or is the opposite of pushing. If you look at the algorithm, remember we said the algorithm is the step-by-step process that you take to complete an operation. The first thing you do, if you want to remove something, you first need to check if there's something to remove, right? So first check if it's empty. So if it's empty, it means there's nothing to remove. So you produce an error, or you just exit the program. We say there's nothing to remove, then you exit the program. But if there's something to remove, then what you do is you go to the element that is pointed to at by the top index, okay, or by the top pointer, because the top pointer is pointing to the topmost element. And remember, with our stack, it's last in, first out, and the last element to be added is the one that is at the top, and it is the first one to be removed. So you need to look at where is the top pointer pointing to, and that's the element that will be at the top, and then you remove it. So after you've removed this, you decrease the top pointer by 1, because now, let's say if there were 5 elements, since you have removed the fifth one, we now need to move our top element to the fourth element, because now it is now the topmost element, and then we return success. Okay. So let's look at this code here. This is more of it looks more of a Java implementation. So firstly, just like we did with our push element, we are going to declare our function. We call it pop, and then it takes an argument of an integer. So as we said, first we are going to check if it's not empty. So here we are checking if it's not empty. This exclamation mark means is not. So it's if the stack is not empty, then we do this. Otherwise, if it is empty, then we just print could not retrieve data, stack is empty. So if it's not empty, what we're going to do is we're going to retrieve the value of the element at the topmost of the stack, and that's what we're going to store in data. Okay, that means we're going to remove this topmost element. Then we decrease the value of top by 1, because top was pointing at the topmost index, which had the last value to be inserted. But now that means our values have decreased by 1. We then also need to decrease the value that top is pointing to by 1. And then we return the data here. So returning the data means we are retaining the what? We are retaining the value of the topmost element that was retrieved on this line. Okay. All right. So let's use this PowerPoint slide to explain this. So firstly, let's use the one where we have got stack push 5 here. So it's saying If it's not empty, so that means we have checked our array, our stack, sorry, and we have seen that it's not empty. It has 1, 2, 3 elements, right? So the first thing we're going to do is we're going to retrieve the value of the index at the top. And that index that is pointed to by top is what? Is index 2, and it has the value 5. So that means data is now equal to 5. We have retrieved 5 from our stack. Then what we do is we then decrease top, because now this index where 5 was is basically now empty as far as we are concerned. We have removed it from our stack. So we need to decrease top so that top starts pointing to the next top element, which becomes 3. So here, as you can see, after popping 5, top now has to point to 3. So we decrease our index, which was 2, by 1. So it becomes 2 minus 1. It's now pointing to index number 1. And then we return the data, and then we do whatever we want with that data. So basically, that's how pop and push operations work. And then generally, in an exam or test, you may be asked, okay, we want you to write a pop operation. Okay, so if I just ask to write a pop operation, all you have to do is to say, okay, pop, you need to write it as a function, and then maybe it takes some arguments, and then inside you then write the various operations of a pop operation. How does it work? Firstly, we're going to retrieve our data, okay, and then after we have retrieved our data, then we'll decrement top, and then we return our data. This is a simple pop operation. The same goes for push. As to write a push operation, you have to write it in the form of a function. Okay, it's very important. Write it in the form of a function, and then write your code in here. If you're also asked to write it as a program, then you need to write it just like a proper program would be written. Now, it doesn't have to be syntactically correct, as we said, or semantically, but it has to be semantically correct. Okay, so we can say if it's a C program, for example, you could say maybe you're just declaring something stdio .h, and you are importing a library, hash include, yeah, and then here then you have your main, maybe this is where you now put your function. So maybe it's a program to pop and to push. So this is where you declare your functions. Void pop. So you write your functions here, and then the other one, let's remove this code to avoid confusion. Then the other code might be for push. So these are functions that you are declaring. And then in the main code now, in the main function, so it's usually int main. So this is the main function in which your code will run. In Yemanji, that's where you are going to pop or push. So you may have to push a certain number, maybe push 5, you're pushing 5. And then when it asks you to pop, you're popping a certain number. Well, pop will always pop the topmost element, regardless of which number it is. So pop may not even need to take arguments. So this is how you write a simple program in C, which includes your imported libraries, then the function definition, and then the main program in which the functions will be run. And in this function, in this main function where it will be run, that's where you're going to write the order in which things will be executed, the flow of the code, the logic of the code, etc. Okay. So let's quickly look at pick is empty and is full. So let's look at is empty first. Okay. So how do you check if it's an empty? So firstly, let's take this array here, the first representation. For us to know that the array is empty, our top should be pointing to nothing. It should basically point to nothing in the stack. So remember, our index is started at 0. So that means for us to know whether the stack is empty, our top pointer should point to -1. Because the moment you add the first element, our top should point to index 0. So that's why here we declare or we initialize our top at -1. Okay, it's very important to remember. We initialize top at -1, so that when we are now checking if it's empty, we say top is equal to -1, return true, which means return that the stack is indeed empty. Otherwise, else return false. So this is a Boolean function. It returns true or false only. So we are checking if the top element is pointing to index -1, which means the moment it's pointing to index -1, it means nothing is in the array. The moment we add an element, we increment top to 0, which is the first element, and then we increment again to 1. But when we remove everything, let's say we remove the first element, it now points to 0. We remove that last element again, it now points to -1, which means it's empty. And then if we check for is full, we're now looking at, remember, like what I said, a stack has got a size. Okay, so we declare the size, the maximum size, as a variable called max size. This is just for this. You can declare it as whatever you want. It's also a Boolean function, so it only returns true or false. So here you're checking if the top element. So let's say in this stack, this is the bottom element, and this becomes the top element. So if, let's say it's equal to 20, the maximum size. If top is now equal to 20, that means our stack is full, so we return true. And that means if we are trying to push something, we should exit our program because its stack is full. Otherwise, you return false, and then you continue to add more elements. Then let's look at pick. Pick is basically retrieving the topmost element. You just want to see what is the topmost element. So here you are returning the value at top. So stack here is representing the name of our stack, which is declared as an array. So arrays can be used to implement stacks. And top is pointing at the topmost element. So that means we can retrieve the value at index top to see the topmost element. So I hope this will help you understand stacks better. And if you have any questions, please ask, and let's help each other. Thank you.